All right. So the next set of special factoring situations that we were going to encounter are what we call are have to do with cubes. And so as you can see here, we've got y is being cubed there and 8 is being cubed there. We just went through the squares. If you have a binomial that where everything is squared, or is something squared or a perfect square, then you use the formula that we talked about. What we're talking about here are binomials where everything is a perfect cube. So of course you've got a y cubed and an 8 is a 2 cubed down here. X is being cubed, and this is a 3 cubed. Even down here, this looks really complicated, but it is a 4x cubed, right? 4x times 4x times 4x, and this would be a 5y cubed, 5y times 5y times 5y. So if all your terms are something cubed, then you then you're going to use the procedure that we're going to talk about. Now, you need to kind of it's helpful to remember what your perfect cubes are so that you can recognize them. 1 is 1 cubed. 2 or sorry 8 is 2 cubed. 27 is 3 cubed. 64 is 4 cubed. 125, let's try that again. 125 is 5 cubed. And we could keep going. 216 is 6 cubed, and of course this list keeps going. But these numbers are numbers that you want to have, you want to remember, or at least be able to recognize, so that when you get when you start factoring something, you you will be able to recognize them for being perfect cubes. So that's what we've got in each of these cases. So let me show you how these factor. The first thing you have to do is you have to recognize what is being cubed. So it's a y that is being cubed and a 2 that is being cubed in this first example. So when I factor it, it's going to factor like this. Y plus 2, because it's a y cubed plus 8. So y plus 2. So you see y is what was being cubed to get the y cubed. 2 is what's being cubed to get the 8 cubed. So y plus 2. And then the second part is actually a trinomial. It's going to be y squared minus 2y. So you'd squared the y. Now you multiply these two things, the y and the 2. And then you last plus y squared. And that's how it's going to factor. You end up with a binomial times a trinomial, and that trinomial, the y squared minus 2y plus y squared, sorry, we got to go back and fix that. That is not a y squared, that should be a 2 squared, which is of course a 4. So y squared minus 2y plus 4, that trinomial, you cannot factor it. It's a prime trinomial. All right, let's try this again with our second one. And so we say, okay, x cubed is an x being cubed. So we put the x there. And 27 is a 3 being cubed. So it's going to be an x plus 3. And then you have an x squared. I like to do it like this. I do an x squared. And then at the end, I do a 3 squared, or a 9. So it's going to be x squared minus 3 times x plus 9. All right. Now, these are always going to be the signs. If this is a plus, then you'll always have plus, minus, plus. And notice, plus, plus, minus, plus. What we're dealing with here, what we're factoring here are what are called sums of cubes, right? We're adding two cubes together, and so this is how they will factor. So let's keep going. Let's keep going with this next example. And you notice the 64x cubed is actually a 4x being cubed plus a 5y, because 125y cubed is 5y cubed. And then you have 4x being squared, so that's a 16x squared, minus 4x times 5y, that's a 20xy, and then a plus 5y squared, 25y squared. And that's how that factors. It looks really complicated, but we can follow the pattern. Now, we should mention this. Let's put this down here. The formula, if you're dealing with sums of cubes, looks like this. If you're factoring something cubed plus something else cubed, it will factor into a plus b times a squared minus ab plus b squared. And there's your formula. Now, these last two examples are not sums of cubes, but they're differences of cubes. And so the good news is we handle them pretty much the same way. The only thing that's going to change are some of the signs. So we notice y cubed minus 8 is a y being cubed and a 2 being cubed. So it's going to be y and a minus because it's a difference of cubes. Y minus 2 is our first little binomial factor, and then we kind of do the same thing. A y squared at the beginning, a 2 squared at the end, but now it's going to be plus 2y and again plus. So if you look at the signs, if this is minus, this will be minus. And then you'll have a plus and a plus. Notice these are always plus in all of our examples. All right, let's do this last example here. And again, we know it's being cubed. It's a 4x being cubed minus a 5y that's being cubed. So there's our binomial. Then you get a 4x squared, so 16x squared, and it's going to be plus. Now multiply the 4x and the 5y to get a 20xy, and then a plus 5y squared. And again, pay attention to those signs, and you notice that it's a negative, positive, positive, just like it was before. And so the formula for differences of cubes, where you have something minus something cubed, is going to be a minus b times a squared plus ab plus b squared. So all the pieces are the same, it's just that the signs switch, except for this last one. Those last plus b squareds are always going to be the same. So that's how you factor sums and differences of cubes, both of which you can factor. Now just remember, you can factor differences of squares, but you can't factor sums of squares. So that's a difference between sums and cubes.